We'll see how far we can get here. I'm going to take this Genesis 35 wing. I'm going to cut some slots in it. So the way I set this up, I've got a standalone video that shows the overview of this machine, or this little contraption. It's a board sitting on 2 drawer slides, and it's just sitting on the bench. This little bow clamps to the bench. So what I do to line everything up, I'll take a straight edge, put it against my wires, and I already have it marked right here. This is my depth of the spar right here. So I got a little dot here and a dot here, so I'll line that up. Now to make sure that the core is positioned right, I come back here with this upright, 90 degrees, and I make sure that this line on the sled matches the straight edge. And if it's not in line, then I move the core back and forth. So I establish where the spar needs to go with this ruler, and then I slide the core back and forth till I get that line 90 degrees to the edge of that ruler, if that makes any sense. Let me see if I can turn this TV on. That way, if you have any questions. Let's see here. Get this TV going. That way, I can't actually see the comments because of the doing this on a cell phone. Suck up a little of my bandwidth here. So let me double check this again since I walked away from it. I'll make sure I didn't bump it. So I just, it's just sitting there. I don't have any weights on it. And this little contraption is sitting on the edge of the bench. And I'll go over it real quick here once I get this cut. And I've already tested the wire tip with a little scrap. That heat up a little bit. It doesn't take much. I'm only running, oh, I don't know, 4 or 5 volts on this thing. And right here is how deep I need to go. And you'll notice when I get to the end of this cut, I don't immediately turn it off. I stop, let the wire relax a little bit because there's a little tension on it. So bring it up to that spot, back it up just a hair, let it sit there for a few seconds, and then shut it off. What I want to happen is I want the wire to melt the foam away from it to where it's not sticking, if that makes any sense. So once it cools, it's a little bit easier to get out of the slot. And you can see it still sort of had a sticky spot in there. So that's my method for cutting the spar slot. Now there's a little melt away right in here, but that's all right. It's just the nature of the beast. And I might change this out to 14 thousandths. This is it's a heavier nichrome. I think I can get a better cut if I shrink that wire size down a little bit. So let me clean this wire. The next step, and I'll do that on camera here, is I'm going to make a spar that's going to fit in there. Now nichrome, I mean not nichrome, but the spar that goes in there, a lot of the plans call out for plywood, like a light ply. I think I can cut the weight down a little bit and make it stronger by using a built-up spar with a carbon cap. This little strip of carbon, it's super thin, but it's metric, but basically for our purposes it's about 1/8 of an inch. And that's what I'm going to do to build this spar up. So it'll be like a worn truss spar out of balsa wood, and I'm going to put carbon top and bottom in that spar. The other thing I need to do when I make this spar, I've got to accommodate for the landing gear clips. And the way this works out on this Genesis 35 wing, it's got the clips go up against the spar right here. So when I'm going to mark that, and then when the actual spar is built, I'll make sure that there's vertical braces on the spar so the clips can butt up against it. And there'll be like X bracing in here, worn truss or an X brace or something. So we'll take that into consideration. Let's see here. Let's get this slot cutter off the bench because I'm done with this thing. Now, this thing just sits on the bench. It's heavy enough where it doesn't move. I've got a stop right here that actually goes up next to this glass. And it's not real critical where this is at in this direction. Let's put this over here. Now this thing, this contraption here, it's just bolted to the bench. Let me see if I can adjust this. I got this cell phone on a tripod this time. No, it's on a gimbal, but the gimbal's on a tripod. So let's unplug the Variac. I recommend highly that if you're going to get into foam cutting, invest in a DC power source, a variable DC power source. I've seen them for 50, 60 bucks online. I don't recommend that you use AC. I've always used it, but it can get you into trouble, obviously. So my recommendation is get you a DC power pack. It's like anything else, I guess, if you're careful enough. It's never gotten me in trouble using the Variac, but if you're new to electricity or foam cutting, you go with the DC. So I just drilled this bench out to hold on to these bolts. And then when I'm done with it, it just goes away. I put this in the bench over there. One thing, you can go back and watch the video. I'll try to go back and edit this, put it in the description, but I've got a video that shows how I set this up. So the tension is variable by moving the wheel collars, but also the gap of the cut right here can be changed by rotating the wheel collars to make these wires closer or farther apart. So just in a nutshell, that's how I adjust tension and the width of the cut. Okay. I think what I'll do, I'll probably copy this plan view right here of this spar on this piece of paper, and that way I'll have a reference of what I've done. So let's see what I come up with here. Here's how thick the spar is at that dimension. I'll probably make it oversized and sand it flush. Let's see, so if I go with 1 3/4, that's about what it is right there. Let me write some of this down. 1 3/4. Probably pretty close to that here. Yeah, let's go 1 7/8. That's oversized. Okay, let me grab a drafting square real quick. Like I said, this is just an unedited live stream here. Your expectations shouldn't be too high. So another little trick, if you're drafting on the fly and you need right angles and stuff, this little gizmo is good. It's got etched into the plastic, so that way if I come in here I can actually line this etch in the line that I've got scribed. And that's how I can get a 90 degree. just like that, and I'll come over here. Let's see, what did I put down? I think it's 1 3/4, 1 7/8. So 1 3/4. Just come over here. 3/4, and then over here would be 1 7/8. So I'll come off here. So this was 1 7/8 here. No, 1 3/4 and 1 7/8 here. Yeah. So basically what I'm drawing out here is the spar. I made some material, is 1/16 inch wood, and I vacuum bagged fiberglass on it, and I wanted it to be the weight of light ply or lighter. I ended up with probably the weight of plywood. I used 4 layers of glass, 2 on the top, 2 on the bottom. The mistake I made, I didn't use peel ply, and I didn't use a breather cloth. And after looking at this test sample, I could get away with 1 layer of 3.2 ounce on this side, and 1 layer of 3.2 ounce here. I could even probably go to 2 ounce glass. But what I was trying to create is a light wood composite that was lighter than light ply, but as strong as regular ply, I guess. So I'll do another piece about this size. I'll probably do it on a video. And out of this piece, I'll probably cut the strips for the spar and also the clips that go in here. And I'll use this material for the clips. So that's a project that's going to come up later. So now I got to cut some wood for this, and I'm going to use 1/8. Let me see, I'll get this camera over here a little bit closer. You see what I'm doing here. Now, I'm not worried about 4-pound wood on this spar. I'm going to grab something here that's relatively light, but it doesn't have to be my best wood. 1/16. I can dig through this and find a piece of 1/8 inch. Let's see what I can come up with. This is a really good piece. Let's see, that might be 3/32. It's pretty good and light though. Eighth inch. So that'll work out good. Now, another thing, if you're off a little bit on this notch, if it's a little bit wide, you can build up with a little bit more wood or something. If it's tight, which you don't want either. You can get a thinner piece of wood or sand this down a little bit. I like to take the wood and run it through there. It should rub like that. And when you slide it in there, you shouldn't see anything move. So let's say you put your wood in there, come back and double check and make sure that you didn't bow or distort the foam. If this is too tight, obviously, you're going to get this effect. Okay, so let me go over here and I'm going to get some blades. I'm going to slice up some wood to build this, and I'm going to build it right here on this plan. This ad hoc plan I just built. Set this over here. Move my camera a little bit. It's always good to get the lawnmower for effect in there. I bought these Z series. They're good blades. They're sharp. I guess the verdict's out whether or not they hold the edge for a longer period of time. So I'm going to square this end up. It's always good to have your fingers away from the edge here. Anytime you're running a saw or knife, always know where your fingers are at. So I'm going to cut this. If I can cut it just a little long, that'll be alright. I can trim it out here. So what I'm going to do, I'm going to strip off some wood top and bottom here. And then I'm going to do a couple more strips, and those strips are going to be my cross bracing in here. So I need to walk over there and get my balsa stripper in just a second here. Now, for those of you that haven't used these things, when you set it up, you want to set this up over a piece of paper, and you're going to lower this blade down till it touches the paper. You don't want this blade rubbing against your workbench. You want it up just a little bit, and what that'll allow you to do is still make your cut without dulling the blade. So obviously I'm going to put the blade against the glass here, but I just take these bags. It's an expensive way of doing it, but I've got plenty of these bags. I'm going to cut these bags, and it's going to be the what do I want to call it, the protective barrier between the drawing and the part. So that way the CA isn't sticking to my paper. So let's set this thing up. Let's go with a 1/4 inch. Never figure out which way to turn this. I always turn it the wrong way. So I'll go a little over a 1/4. And that way I can sand it flush. So let's cut 4 of these pieces. Now I've got 4 of these wings going. 1, 2, 3, and I got blocks for another one for this 35 size Genesis. And each one will be just subtle difference. There'll be minute things that are a little different. Okay, so let's go with a little bit thicker than a 1/4 with a clips go. I'm just going to guesstimate. I'll just crank this out a little bit. Now see, it doesn't cut all the way through, but it snaps. So I'll lay this down here. Now, I'm not sure, this carbon fiber, you notice I didn't grab this as it was falling from the bench. That comes from experience. Let it go. So I think what I'm going to do, this carbon fiber, it's going to be laminated to this balsa wood. I'm going to put this carbon fiber on the inside. So anytime you have carbon top and bottom, what really gives it the strength, obviously, because see what happens here, it's very flexible. What gives this carbon the strength is you don't allow it to flex, so you transfer the bending load into the directional tension load. So if you have the carbon on the inside of the spar, and it's not too far inside, but you have end grain like this coming up, and that end grain against this, directly against this carbon, in my theory, will give you the strength. Now, I'm not really sure it's that critical, but that's my story and I'm sticking to it here. So I'm going to have vertical braces here. The carbon's going to be laminated underneath this and this. It'll be carbon, and then there's going to be a couple worn truss braces in there. So I don't know. The verdict's out. Is it going to be lighter than light plywood? I don't know. We'll find out when it's all done. So I need, let's see what I got here. I'm going to have to go over there and chop this off on disc. So I'll go 1/8 and 1/8 will give me an extra. Let's see, I think I've got a Dremel over here. I got a Dremel with a carbide bit. Let's see what this one is. Dremel with a drum sander. Tell you what though, instead of going over there and get the cutoff wheel, we're just gonna use this. We're gonna notch it and break it. Like I said, it's going to be trimmed anyway. Now, when it comes time to laminate carbon to wood, you don't have to do anything to the wood, but I like to take the carbon and rough it up a little bit. Give it some tooth. You never know, it might have release on it or something. This is pretty coarse. It's digging in there pretty good, but that's all right. Give me a good bond. If you look at this carbon, it's pretty slippery. It's pultruded or something, I don't know. You know, we'll see if we can keep from bending and gluing my fingers to this. Once CA hits carbon, don't ask me why, but it's like right now. There's no lag time. It pretty much cures immediately. Get these all laid out. I think this is pretty straight. Let's sand this a little bit. If anything, I'm taking off that little tick mark where the blade didn't go all the way through there on the balsa stripper. I'm going to grab some CA here. And I'm going to get some plastic for my finger in case I need it. I don't think I'm going to need the kicker, but I got it here just in case. It wasn't really very smooth, but I got her done. Stick number 2, we're gonna change our technique. See if we can make it a little bit smoother. Put the wood on the carbon instead of the carbon on the wood. Now I'm not worried about thickness. I mean, once this little spar is all glued together, I can run a sanding block over it and make sure that everything's flat. So this is the way it's going to go. Carbon's going to go on the inside. Like I said, if I make this too short, I can always cap it with more wood. I'm not worried about that. I'm going to get my gravity block out here. So this is basically building on the fly. Come in here. I'm going to cut these here. If they're just a little oversized, that'll be alright. Like I said, if it's a little over, a little under, we can compensate for that as far as making it the same depth as the foam wing. Now, one of the things I want to do is make 2 of these the exact same dimension. These are the little vertical ribs that the clips are going to go up against. I wanted the landing gear clips to bottom out, top to bottom on something. That's where these come in. So I think you can see, yeah. So I'm going to put a little CA on these. I like to use this to move it. That way I don't get my fingers in it. And I will kick this one. And what did I do with the other piece? Did I lose that already? Okay, here it is, sitting right there. Good grief. I'm just lining these up right here where the clips are. big can of kicker. It's enough kicker to do a whole airplane the way it comes out of that spray can. So you get an idea right now. Here's where the clips are going to go right here, okay? I'll just put an X brace or something in here. And this has got to be open because the bell crank obviously is going to pivot in this area. So I'll probably come over here. Let's put another vertical right here. We'll leave this open for the bell crank. And then let's just do a worn truss through here. I think that'll be fine. So let's just say the bell crank is positioned. Let's get this thing in there. Give me plenty of room. Let's come in here. Now really, if you're building an airplane and you want to build a stab or anything, you could do the same thing. You just draw it out real quick, throw some plastic down, start framing it in. Really simple stuff. Easy to do. I made some jigs to cut this stuff super accurate. If you're cutting a bunch of them, there's other videos on that. Okay, let's see where we're at. That'll come in. Let's come in about right there, 2 inches. That way if we have to slide the bell crank over a little bit, we'll be all right. So it'll be right here. It's the old TLAR engineering. Gravity's great. And let's stick some cross bracing in here. Not going to need any kicker on this, I don't think. Now right now it doesn't really matter, it's sliding around. I've already got my outline set up. I know it's a lot of work for a spar, but we're going to weigh this. I got 4, I'm going to do 4 of these wings. I'm going to weigh everything, and I'm going to see, quantify, I guess you could say, what each process adds in weight or subtracts. We'll see. On these wings, I'm gonna do some balsa and glass. I'll probably just do one of them. I'll use it for my airplane, just like a traditional, just 16th inch balsa, you know, like the old style. If you guys are watching this, you're wondering what airplane this is for. It's Steve Berry's 35 size Genesis. He redesigned and came up with a Genesis. It was and Bob Hunt looked at it and sort of guided him on what to do. So it's his iteration of it. Now, if you need the plans to this, I'll give you that here in I don't know, in a minute or so. But you got to order them from Steve. He's got the PDF files, and pay him the money and get your file, and then you could go, I don't know, FedEx, UPS store, Staples. You know, there's a lot of different places you can get the copies made. And I recommend supporting him. And spend a lot of time on them. So I also recommend, if you get these plans from a buddy and not from Steve, make sure you send Steve the money. You know, he did the work. And it's the same thing, you know. Stunhanger's got some plans at different things that are drawn up. You know, make sure the person gets the money for their design. So this looks pretty good. Obviously, you got, just like any other structure, you got glue, ease out. Let's get a little bit more kicker on there. Make sure everything's fully cured. Now this, yeah, this will be a really good spar. Okay, let me get a little sandpaper on this thing. I got two different grits here. Let's start with the fine. Go with the coarse over here. Well, it's going to be hard to sand too much because you're sanding against that carbon. All I'm trying to do is get all this glue squeezed out. But I think it's important to have the carbon next to the end grain. What'll happen when this little spar is under load, the carbon is want to squeeze in and crush, and the crush resistance is through here. So now let's see how close I maintained. So it's a little tight up in here. So what I like to do, instead of sanding it, I just take it, clean out the, sometimes just clean out a little fuzz. Now you can see, I'm not even sure, yeah, it needs to be sanded a little bit. So yeah, that's a good fit, and it's a little proud, but it can be sanded. Now this hole here, that's where I had the extra melt away and sort of done on purpose to get the wire out. I'll go ahead and just plug that with a little balsa wood, put some grain down in there, and now I'm ready to go. These spars, I gotta make another one and glue it into the other core. And what'll happen, I won't do it tonight, I don't have time, but basically these will be glued in, and then I'll cut the clips, and I'll go through the same process where it goes through the wire, and I'll cut a slot here and a slot here, and that's where the landing gear clips will go in. The landing gear clips will be pre-hollowed, okay? and that's why I went with this fiberglass material. I wanted to go with a composite material on the clips because I could get the actual profile really thin and maintain the strength. The trouble is with light plywood, by the time I hogged the clip out and hollowed it, it would get too thin, and I was afraid it would splinter. So this fiberglass laminate on balsa, this composite ply will add a lot of strength and hopefully not any more weight than light ply. The clips will be pre-hollowed. So then this is glued in and the clips are glued in, pre-hollowed, and then I vacuum bag the wood down. Once the wood is bagged down, then I'll core it out. Now, I got to make an adjustment. Is the profile of the clip has to be within reason of the coring, so it has to be fairly thin, you know, because when I core it, it'll follow this template and it'll follow the tip template as you core it out. And then probably what will happen, it won't ever be perfect, but the wire will be riding over the inside of the clip somewhere. And if it's not beautiful, it doesn't matter. All you're doing is getting weight out of it. So I'm thinking on this clip deal, just give you a reference. So the landing gear clip would be like this, and there'd be a little hump right here, and that's where your gear block would go. Give or take a little bit, this is the profile probably of the inside of the clip right here. And then of course when I core it and just knock everything out. So I need to make more of this. This is, in my opinion, too heavy, too much resin, too wavy. I didn't compensate for a lot of bad things, but no big deal. So I'll do another one of these off camera. I try to maintain a little bit of a flow here, even though you know it's all live, but boy, you get too bored. So I'll set these aside. I can use these again. I'll probably just use another bag then. Maybe I'll use this half. Save that. Okay, so now I've got pristine vellum here. You know, I laid up a spar, still nice and clean. I got enough carbon to do my other one. Now, let's grab another core. Off camera, I actually put this leading and trailing edge on. Now, the wing that I showed you here, okay, this has got the leading edge cut into it. And this is like Bob Hunt's Generation wing, you know, it's got the accurate leading edge on it. Now this one, it'll have the same leading edge profile, but it's going to have wood on it. This is the core that I was going to stick in my airplane. I'm going to have like 4 or 5 of these cores probably. So the thinking is on this one, instead of wrapping the whole core with 3/4 ounce cloth and bagging the preformed sheeting over everything at once, I was going to take the 3/4 ounce cloth, once I get this sanded and this sanded, lay the glass cloth wet out on the core, put the sheeting on it, top and bottom, and then bag it. So by doing this, it saves molding the leading edge, wetting it down. It saves a little bit of time. Now the drawback to this is if you sand this correctly or incorrectly, and you don't follow your center lines and you're not careful, you end up with less than perfect, and that's not good, especially on a leading and trailing edge. So let me grab my Zona saw wherever I put that at. I'm going to knock these off. No reason to actually carve anything else that you don't need to carve. Now I got, let's see, this woodworking glue. This is what I glued the leading edge and trailing edge on with. It's the waterproof exterior and interior, so it's completely waterproof. The difference between this and the other two formulas, the original and the water resistant, this has got wood dust in it or something. You can see how it's grainy, and it's got a lower viscosity. It's thinner. So this is what I like to use. It's a little bit thinner, which works out for what we need it, where I need it for. And it's 100% waterproof. Now, it's really not going to matter. I mean, a waterproof joint surrounded by wood, if that much water gets to this thing, you're in trouble anyway. You got more problems than the glue scene. So what I like to do, it makes it a little bit easier. I set this thing back in the cradle. This isn't the right cradle. This one's been cut down shorter. But that's all right. It'll support it a little bit. This is a shorter core. This is the outboard. And I just go through here and start planing. Back this camera up a little bit. This is a Master air screw. I think they still make them. It's a little razor plane. Master air screw was the same one that made those, you know, those black plastic propellers. And they also make this little balsa stripper. Master air screw. The next generation, I think their colors are blue or something. But these two things, I think you can still get them. You can get on Amazon, look on Sparky's link. He should have them. That way, give them credit. I've got a little extra glue squeeze out in some places. I tried to clean it off as much as I could, but where the tape was, I wasn't able to get under the tape. So, just ever so slightly work this plane down. This is the wrong cradle, but it'll work. If you have trouble with the razor plane biting too much or gouging, just try it from the opposite direction. If you have straight grain, it won't matter, but if you have grain that's running sort of funny, this blade will want to follow the grain, so it, not so much on balsa wood, but I know with hardwoods you got to be careful how your grain's running, and then compensate for that. Now there's places with glue squeeze out. I'm going to pick those little spots out. It's easier to pick them out now than it is trying to rake them out with the plane. Yesterday the glue was rubbery. Today it's a little bit harder. Another day or two it'll be really hard. So that saves me from digging into that glue. At this point I start using my fingers. You can look at it and use your eyes, but believe it or not, you can feel the lip quicker than you can see it. Doesn't have to be perfect. Matter of fact, you want it just a little proud of the foam. You want to sand down to the foam, not razor plane down to it. Now, when I do the leading edge, basically, this contour here, this angle, the drop off is what I want to duplicate on the wood. And once you start sanding this, you keep referencing this profile with the center line, and it becomes obvious if you start straying from that center line right here. It becomes really obvious when you, with your eye, you draw that line all the way out there. It's obvious if you're not sanding it correctly. Another thing that needs to happen is this center line needs to be extended out into the wood. The leading edge is a little bit trickier because you got that angle there. Go slow. Okay, at this point, it's important to get a long sanding bar. Now what you can do, I've got one here that's got coarse grit and fine grit. If you want, if you're careful, you can use a coarse grit and sort of get the waviness out of it. You're not going down to the foam yet either, so stay away from the foam. Usually at the ends is where they come up a little bit fat with the razor plane for some reason. Now that I've got it really close, I'm going to switch to the long bar. This is Mecklenburg Duncan. I bought this probably in the 90s, 80s and 90s. I think you can still buy this stuff in a hardware store. If not, you go to metal supermarkets. They have all different extruded, different shapes. So at this point, you got it really close. You're still staying away from the foam. Now let's say you're sanding, and let's say it's a little proud right here and here, but not here. What you can do, this is sort of technical, but you angle the bar so the sandpaper isn't touching here. So you angle it like this, and what you're doing is sanding here and not here. So by angling the bar, if you had a hump here, you turn the bar this way at an angle, and then it allows you to sand right here. I know it's very subtle, but it's what you want to do. And then of course at this point it's going to come up and I'm going to eyeball it. And it's really close. It needs a little bit more, but it's really close. So as you notice, I'm not actually sanding a radius in it. The only thing I'm trying to do right now is sand a continuation of the foam. And how I know I haven't gone too far, when I get this sanded, I look, and I can always double check with my center line. So I'll verify and I'll extend this line out onto the wood, and I'll make a verification that it's in the center of what I just sanded. So the center line is crucial. It allows you to maintain the accuracy. The integrity of your core. Used to be, when I was really ambitious, I could cut a core, set it up in an hour or so, I don't know, whatever it took me. I'd cut a couple of them. I used to use foam safe CA, so this CA was instantaneous, but it didn't melt the foam. I glue the leading and trailing edges on, and I shape them. I glue my sheeting together, sand it, and it would be in the bag in one day. The next day, I'd core it out. So between 2 days, or a day and a half, or even less than that if you count the hours, I was able to come up with a core that was finished. Most of the stuff I did were wings with the fuse mounted gear. They didn't have the clips. Just do a lot of RC sports stuff. Now on this core, this is one I'll probably obviously put in my plane. It's going to have a fuse gear. The other ones will have the clips and everything. But on this one, it's like there's a little melt away right here, just ever so slightly. And it's not much, hardly anything, but what I'll do, so I don't get any dip, I want full contact, I'll take some of this spackling compound, and I'll run it down that little teeny seam. I don't know, there's 20,000 hits on this video. It talks about Cox Manufacturing. It's AI produced. So I'm not sure how many mistakes they made on this AI video as far as stats or whatever they're talking about. But I do know that there's more than, well, there's 3 letters to the word Cox. They said there's 4 letters in the, they made some reference to it. And they talk about 25 millionths of an inch. And I'll tell you what, after machining and doing certain things in a machine shop, if you're dealing with 1/10 of a thousandth, you know, it's 77 degrees, it could be 85, 90 in the shop, you know. If you're into the millionths of an inch, you better specify at what temperature you're actually machining the metal because of expansion and contraction. And I doubt very seriously that Cox Manufacturing is holding that much tolerance. I agree that they had the best tolerances, but I doubt that they were actually running it that tight. On another note, Jim Van Arsdale from King Machine, back in the 90s, I believe, when he was making the Shuriken engine, Cox Manufacturing came in there and they paid him a visit and wanted to check out his operation. What had happened at that time, Cox got out of the basically toy manufacturing according to the video, and they started catering to the competition modelers with their TD line of engines. So Cox would have everybody that was competing in a half A event at the Nats or whatever was using a Cox engine. Fast forward to Jim's engine, the Shuriken. You had a 049 that was basically the power of a 15. I've seen a couple cases where Jerry Caldwell with a free flighter, with a half A size free flight airplane, with a Shuriken engine on it, it probably went 30 feet in the air and the wings ripped off. And it was really like the power of a 15. So they were having to really be careful. It wasn't a half A anymore. But I think Jim Van Arsdale on King Machine was starting to worry Cox because his market wasn't the toy manufacturing, it was the competition. And I don't think Cox wanted to lose the reputation of not winning any events, especially when that turned out to be their bread and butter towards the end. But it's an interesting video. It talks about private equity coming in there and getting involved in the hobby to make money, not having any idea on what they were selling. So this is really good. It's at this stage it needs a little bit more sanding, but at this stage right here on the leading edge is when I start to actually radius it. Try to keep pretty much at all times, just keep the sanding bar away from the foam. So, let's see, I was going to do something else, I can't remember what it was. Can't be too important. But that just sort of covers how I made the spar, and also did some leading edges and trailing edges. something else, but I can't remember. I was thinking about doing the another iteration of this laminate for the plywood composite stuff. I'll probably wait on that. So hopefully I didn't miss any questions. The trouble is if I'm standing here working at this bench and I can't see the phone. Let's get this thing here. I can't see the phone, and if I'm not looking at the TV screen, I can't see the questions you guys ask, which is, let's see how many. 3 people. So but that's really pretty much. If you go back, I did a stream, can't even remember now, a couple days ago, and I did one the next day where I actually cut these wings out. And go back and watch me do that. Everything I've done here, with the exception of this, was a standalone video somewhere. What I have to do now that I've got this shaped, I gotta cut this off here towards flush. I got overhang here, and I got to make another one and trim it here, and then of course the clips will go right against this area here. And what you can do, if you don't want a stress riser right here, you can take a little bit of carbon and you can stretch it out a little bit. Or if you're really worried about it and you're flying off a lot of grass, and you can actually take some glass cloth, you know, and go over this area here underneath the wood or above it if you think that's necessary. So, but anyway, that's pretty much it in a nutshell. The other day, I did do this thing, and I'm contemplating on a control line fuselage. So, I know it doesn't have anything to do with control line, it's a pod fuselage. So, I made this pod, and the reason for the pod, I'll show it to you, and it's probably old news for a lot of you, is it's just a way of holding a lot of different radio gear and a motor and a landing gear. And it's sort of like a do-all airplane in a way for sport. It'll be a thermal hunter, it'll be an old-time looking thing, or if you do a shoulder wing, it can be a really fast sport airplane. It just depends on where you put the wing and the stab and everything. And I've got a little bit of time, and I was thinking about doing a fuselage for a control line stunner. So the idea behind this pod, the carbon gear mounts here. See if I'm in the camera. Carbon gear, your electric motor mounts in here. There'll be a hatch somewhere. You might access the battery through the scoop, I don't know. Now, as you can see, there's no fuselage extending back, so that's where this comes in. I did this, I made a plug and I made this mold. Okay, when this comes together, it's almost like a egg-shaped tube. Right here. So if you take this tube, which would be your fuselage, it inserts into the pod, and it'll probably go through the pod and it'll mount up in here somewhere, but it can come back here. So as you can see, you can cut this tube off anywhere, okay? You can change your tail moment. Not only can you change your tail moment, there'll be another bracket that allows your stab and your tail section to bolt to this pod fuselage. And then options here, you can run a tube, like a aluminum tube or carbon tube, through the pod, through the fuselage, and then your wing would slide on a tube. Now if you don't want to do that, I was going to make another, it would be like a, whatever you call that thing that comes up, a pylon. The pylon would come down and it would attach to this pod, and your wing would sit up here. And then you put a sailplane wing on here. So this would be a floater. So it could go from a fast sport plane with a shoulder wing or on thrust line wing to like a really high dihedral, anhedral, whatever you want to put up here. So this one configuration can go with a lot of different variables. And that's why I made the pod and this separate, because it could all be changed. And then I'll make the pylon. And then of course the gear is pretty standard. And it's really a test bed, okay? One of the problems was, and it's like going forward making a control line fuselage, it's like, okay, where do you put the seams at? Where is the hatch? Where is the tail going to come on and off? How are you going to make it take apart without making it come apart? So anyway, this is sort of a test bed. This stuff right here, this configuration, when you join these two halves, the reason why you don't see any key marks, okay, is because the best way to join these two halves in the seam is a bladder. So I didn't want to mess with that at this time. Normally you put the mold halves together and they key together, and then you have access to where you can run some seam tape in there. Well, this is almost 3 feet, so there's not enough. It's too hard to get down through a hole and get the seam tape in there. So the way this was going to be constructed, it's going to be like that wheel pant with a flange. There's going to be 1/8 inch Lexan laying around this mold, the perimeter. I'm going to have 2 strips of Lexan, top and bottom. The Lexan is going to hang over the mold, okay? And as everything comes up, it's going to create that flange. So when I take the left and right side and I put it together, it glues together on that flange. And then on high stress areas, maybe at the tail or the nose, I can still go in there and put just a little tape, you know, back in here. So if I get all this figured out when it comes time to do a control line airplane, basically the fuselage would be a block, perfectly carved and finished. The hatch, let's just say it was a jet style. So I'd have a block on top of a block, and it would all be sanded and contoured into one shape. Let's just say that this was right here, this came off. You tack glue the blocks together, you shape the whole thing, but then when it came time to make the mold, you made one mold for this, and then you run the parting board here, and you make a mold for this. But you're making molds off the same block, if that makes any sense. So when you start getting into all these curves and all these different neat things that really make it look cool, you have to have more than one parting board. You have to have a parting board for this part, a parting board for this, or whatever. It's get complicated, but if you get it all laid out right, it'll be a really cool process. So that's where I'm at. This was just a fiddle pod thing. I'm not getting much done on some of the control line stuff because this is sort of a test bed to get me where I need to be there. When it comes to a full-size stunner, I want to be able to have a process that I can rely on that I know works. Otherwise, I don't want to get stuck in something that's basically trying to figure it out on the fly. I want to try to, with this little stuff, I want to get it figured out ahead of time. So anyway, that's about all I wanted to cover. I thought I'd turn on the camera and cover some of this crazy stuff I was doing on the bench with the these foam wings. Here's a pile of them here. There's 4 right there, and I've got a block that's sitting over there that's ready to be cut up into blanks. I forgot to give it to you. Let me give you Steve Berry's email address. If you want this plan for this Genesis 35, this is the wing I'm cutting here. I'll give you this real quick. I don't know how well it'll show up, but it's professionally done. I was thinking about making a mold for this fuselage, to be honest with you. It's straightforward. Little scoop, and one of the things I changed, I open up the back and make it wider back here. And what that would allow me to do is get a bigger control, or have more room for the control horn back here. And it allows the air to come through. So there's the fuselage. I got his email address on one of these plans. He sends them out in the 3 sets. There's 3 PDFs. And I think when I got these printed, don't quote me, but I think it was around $12 for all this paper. But that was for the printing. Well, as luck would have it, it's on the last sheet. If I would have looked at this one first, I'd have been alright, wouldn't I? I think. I'm going crazy. I know I wrote it down here somewhere. But this sheet has got every rib in it. Here it is. I was overlooking it. Okay, let's see if I can get this to come out on the camera. It's right down here by my left thumb and my right thumb. Let's see here. sbmodels@pm.me. SMB models. Good grief, SMB models at pm.me. So send him an email if you want these plans. And I'll tell you what, if you wouldn't build this airplane, it'd be worth the money just to get all these ribs. I mean, this is a very good wing. You could use this in any 35 size airplane. So, stunning. It's very good. So, anyway, too many projects, not enough time. And then for about 5 weeks, I got involved, I don't know, it's about a month ago, into a real life job. I was in there doing some pattern work for some people, and I got involved in that, and that was a full-time 8-hour day for 5 weeks, so that kept me busy. Got plenty of cloth over there to make my molds. Here's my, here's my professional setup for my YouTube. If I'm going to edit a video, I just record it on the GoPro, take the card out, put it in the computer, and edit it. And this is my patented stand right here. You got to keep a half gallon to keep it heavy enough, but it works good. So anyway, anywho, that's about all I got for you. I'll jump off here, and I think when I come back on, I'll probably do some sheeting. I'll show you my way of sheeting, which they all work. I mean, I've seen Bob Hunt's got a great way of doing it, and everybody's got their way, and it all works out good. But I'll show you what I like doing, and we'll sand up some sheeting, and we'll get some of these cores over here into the bag. So thanks for dropping by. Hour and 32 minutes, good grief. That went fast. So thanks for coming by and watching, and I'll catch you on the next one.